So start with those two statements. F has a relative max when, F has a relative min when. And this was, hopefully, those are easy because that's what was on the test yesterday. So what's the first one? When F prime, not necessarily is 0. So it might be 0, but it definitely changes from positive to negative. So you're right, if it's, as long as it's differentiable, its derivative would be 0. But its derivative being 0 is not enough to say that it's a max, because a derivative of 0 could also be a min. Kylie, you good with that?
Yeah, I'm good.
The fact that if its derivative is 0, that doesn't guarantee it's a max. It might be a min.
It changes.
It's got to be the change thing.
Yeah.
F prime changes from negative to positive. Okay, that's strictly review from last unit, but that's like the main thing from last unit that we'll use today for optimization. In our previous unit, we analyzed functions, increasing, decreasing, concavity, maximums and minimums, points of inflection, all that stuff. In this unit, we will apply this knowledge to situations, which is another way of saying word problems, right? This section is called optimization. We might be asked to maximize profits, we might be asked to minimize cost, maximize volume, minimize, a whole bunch of different questions we could ask. Alright, so this first example, like the example is pretty short, but we're going to show tons of steps to sort of illustrate the process we want to see for one of these problems. So the statement, and I mean, yeah, 5 steps, but as you read the steps, like most of these you're going to be like, yeah, of course you do that. Like, why is that really worth calling it a step? Find 2 positive numbers such that the sum of twice the first and 3 times the second is 150, and their product is a maximum. Okay, so one little sentence, but that's a mouthful there. So let's back up here. Even before we get into what the steps are, find 2 positive numbers. So we'll be looking for x and y in this problem. So when we get to the end, make sure we say x equals and y equals. Chances are you only find one at a time. So this would be one of those spots where you solve it and you get x equals 12 and you think you're done. Make sure you find both positive numbers, such that the sum of twice the first and 3 times the second is 150. So 2x plus 3y equals 150. And their product is a maximum. And so we want to maximize their product. Okay, 2 numbers. They're some constraint, so like they're related to each other. 2x plus 3y is 150, and their product is a maximum. Step 1. Ask yourself what is being maximized or minimized, and write the equation for this. You may or may not be given this equation. Sometimes they just give it to you. It's nice when they give it to you, because that sort of takes care of step 1. Here they didn't give it to you, but they said we want to maximize the product. Oh, they did not give us a formula or an equation for product, but what's the product of x and y? You know, you're like, well, x times y. X times y. So what is being maximized? In this case, it's the product. And we don't always use this language, but if we need to differentiate, we'll call this the primary equation. This is the primary equation, meaning it's the one we want to maximize. It's the one we want to optimize. So that's the one we'll take a derivative of in a moment. you. Mia, you need this one. Step 2. If the equation you wrote is in terms of more than one variable, it is for this one, write it in terms of only one variable, if possible. It's almost always going to be possible for us because we wouldn't be able to work these problems if we couldn't do this. So it will be possible. This usually involves using other information in the problem. Okay, so p equals x times y. That's what I want to maximize, which means I want to take a derivative of it. But if I take a derivative right now, it's like product rule and chain rule and two derivatives, and no, I don't want to mess with that. So if I could solve for x or y, then I could make my life a little bit easier and only have one variable. Well, we have an equation that relates x and y. So let's use that to help us solve this problem. And since it's kind of the helper equation, we call it the secondary equation. So I'm not going to be taking the derivative of that, but it's going to be helping me. It's the helper equation. Let's see. It doesn't really matter if you solve for y or solve for x in terms of like difficulty, but also in terms of mathematically, it's either way. So I guess I'll just solve for y because that feels like what we normally do. So move the 2x over, divide by 3. Okay, but my goal is to fix my primary equation, meaning get my primary equation in terms of one variable. So I can take this statement for y, or that expression for y, and plug it in. And p equals x times negative 2/3 x plus 50. Okay, step 3, analyze the equation. And by the way, these are not usually like memorize these steps and apply them. It's like this is how you think through the process here. So let's look at our equation. Can you tell if it has a max or a min? Not when it's written like that, I can't. But if I'll distribute that x, I think I know what that looks like. Right? I mean, not specifically, I don't know, but what shape is that? If I graphed it, what shape would I get? What shape is that? Quadratic. Be a little more specific. Yeah, it would be a downward quadratic because of that negative. So I certainly couldn't put it on a coordinate plane without knowing some more details, but I definitely know that it looks like that, which means that there's a max somewhere. And that's what we're looking for. So I feel like we're on the right track. This equation will give me a max. It's an upside down parabola. So I think I'm on the right track. But these are things we want to think through rather than just apply a process, the same process every time. And this is what starts to get people. They want to learn a process and not understand things. I think that was a little bit of a problem for some on the last test. There wasn't a lot of process questions on the test. There's a whole lot of concept questions. This will help with that as well. So think about what's going on. Don't just blindly follow the process. Okay, does the max or min occur at a relative extrema or an endpoint? Yeah, relative extrema for sure. Sometimes this equation is a parabola that definitely has a max or a min. Yeah, it does for this one. Okay, so I want to find the max or the min, the max in this case. So back to what Kylie said earlier, take the derivative, set it equal to 0, and then we'll worry about, actually we really won't have to worry about because we know the plus minus stuff should work out that way. You said very early on, at the very first thing, you said f has a relative max when f prime is 0.
Yes.
And that's not quite right, but you're right that we need to find the derivative and set it equal to 0. So it wasn't technically correct, but it is definitely something we will use. So p prime, let's see, that would be negative 4/3 x plus 50. And we'll set that equal to 0. Critical numbers where derivative is 0 or undefined. That is definitely part of the steps that you'll need to use. Take the derivative and set it equal to 0. So negative 4/3 x equals negative 50. X equals 3 times 50 is 150 over 4. And we could reduce that, but we could also leave it alone if we don't want to mess up our reducing. So that's our critical number. If you're not sure if your critical number is a relative max or min, use a sign chart for your derivative to determine what you have. And be sure to consider the endpoints if endpoints are involved. Now, for this particular problem, we already know that it's an upside down parabola. So the only critical point is the maximum. So I don't have to do the sign chart. I could. I know what I would get. But I don't have to do that for this one because I already know that that's a maximum. And then this, I kind of mentioned this earlier. Make sure you answer the right question. So x equals 150 over 4. Like, I got it. That's right. And it is right. Except, in fact, I would add this as a last step. Reread the question. Like, make sure you answer the right question. So find 2 positive numbers. Oh, we've only got one of them. So we're not done yet. We haven't done anything wrong. We've done a lot of good stuff. But we're not done yet until we say what y is. So negative 2/3 x, which is 150 over 4, plus 50. Again, if you want to, we can reduce that if we want to. But if you didn't want to, if you're like feeling lazy, like it's Friday, I don't want to mess with things, like I'm done. That's an okay answer. I think it reduces nicely because 50 over 2 is 25. So yeah, it reduces to 25. But you don't have to do that. Okay, so big picture, a maximum occurs, well, you know where a maximum occurs, at the top. Minimum occurs at the bottom, where f prime changes negative to positive. So we're just using that same idea today, but we've got word problems to go with it. Number 2, a ball is thrown straight up in the air from a height of 3 feet. Its height after t seconds is given by this equation, where s is in feet. What is its maximum height? Okay, so we want to maximize height. We have an equation for height. Oh, this is good news. Like, we have the equation. The equation we want to maximize. Already given. That's our favorite kind of problem right there. Like, you didn't have to come up with anything. 3 or 4 examples from now, we're going to have to really think to come up with the equation. But for this one, it's like, here's an equation. Optimize it or maximize it. Like, good, I can do that. So let's think about this one as well. What does this equation look like? What does the picture of that look like? If we graphed it, what would it be?
The same as the last one.
Same as the last one. So it's going to have a maximum. In fact, its only relative extrema is the maximum there. So I think this is really similar to the last one. So why don't you see if you can finish this one? Take its derivative, set it equal to 0, and that will almost be your answer. So again, take the derivative, set it equal to 0. Be careful, this answer is not what it wanted. It wanted its maximum height. So make sure you always, give what they're asking for. Now, if you stopped at 5/8, I'm going to give you most of the points for this problem because you did all the hard work, but you hate to leave points on the table when it would have been so close. Number 3. A rancher needs to make an enclosure for his herd. The enclosure will have 2 areas sharing one side, as shown in the figure below. The rancher has 500 feet of fencing to use. What dimensions, x and y, so there's what we're trying to find, will produce the maximum enclosed area? Okay. So what's the area of that double pin or double enclosure? XY. Okay, that's what I want to maximize. So that's what we've been calling our primary equation. So this one's very different than that last one. It did not give us an equation, and it's going to need another equation because this has 2 variables in it. So is there something we know about x and y, like something else we know about x and y that relates the 2 values?
3 walls representing y and 2 walls representing x.
Okay, so there's 3 y's and 2 x's. And what about those 3 y's and 2 x's?
You have 500 feet.
They add the 500. Like we'll assume we'll use all of the fencing because that would certainly allow us to make the biggest possible enclosure. So yeah, 3 y's, 3 y's, and 2 x's add up to 500. So now this is more like that first one where we got to solve the secondary equation, the helper equation, for x or y, and it never really matters which one you do. Plug that into the primary, then take a derivative and set it equal to 0 and figure out exactly what's being asked. All right, would you like to solve for x or for y? Do you have a preference? Okay.
I think x.
Why x?
Because
Just want to be different, or?
I don't know, I already did it.
Okay. Well, most people said y, so I'm going to go y. You can keep working, and we should end up at the same spot.
Okay.
3y equals negative 2x plus 500. If you'd given me a better reason to solve for x, I'd have done it. Because there is maybe a reason to solve for x. I thought Greg was going to give it to me. If you solve for x, you'd be dividing by 2. And so at least the 500 over 2 would have been an integer rather than a fraction. But it doesn't really matter. So area equals x times y, but now we have a new expression for y. Negative 2/3 x plus 500 over 3. So area equals negative 2/3 x squared plus 500 over 3x. That's kind of ugly, but I know what shape that is. That's another upside down parabola. So I know if I can find where the derivative is 0, it'll have to be the max, because that's the only spot that would have a derivative of 0. So a prime would be negative 4/3 x plus 500 thirds. Oh, this is going to work out okay. All those thirds are going to cancel out on me here. So negative 4/3 x plus 500 thirds equals 0. Right, like this is like the piece of the problem that matches what we did last unit. Take a derivative, set it equal to 0, figure out if it's a max or a min. I'm going to multiply through by 3 to make all the denominators just go away. 4x equals 500. 500 divided by 4 would be 125 in feet. and that's the only critical point. I already know it's a maximum, so I don't have to worry about doing a number line and checking positives and negatives and all that stuff. If you don't know what the shape looks like and you've got a cubic or something, then you might have to set this up and figure out, is it a max or a min, right? Because you sure don't want to help this rancher out by giving him a minimum area for his enclosure. Are we done with this problem? Go back and reread it. What am I missing? Or what's left? The value of y. So I'm almost done. Y is negative 2/3 times 125 plus 500 thirds. And not feeling particularly helpful to the rancher, I'm going to just leave it like that. This would be one. It's still safe to use the safe stop, okay? So that's fine. But in multiple choice tests, you know this, they're never going to leave it as a safe stop. Plus, this is a real world problem, and somebody's trying to get your help, so you do all the math. You're not going to come back and say, okay, so here's your y dimension. It's negative 2/3, 125 plus 500 thirds. And they're going to be like, what? So it's fine for math people to leave it like that, but make sure you're able to translate that into something other than that. All right, let's do one more, and then we'll stop after example 4. The open box problem. A manufacturer wants to design an open box having a square base with a surface area of 156 centimeters. What dimensions will produce a box with maximum volume? Okay, an open box, square base. Okay, square base. So that means my base is a square. And then my height, I don't know what the height is. I'm sort of exaggerating that it's not x. I mean, I guess it might be x. We don't know what it is. Art class on how to draw an open box. Okay, what dimensions? Okay, so already I'm thinking, don't forget to find x and y. I'll probably find one of them before the other. Will produce a box with maximum volume. So I need a formula for volume. That'll be my primary equation, and I think I'll need a helper equation to go along with that. So, Bryce, how about the volume of that box in terms of the variables I have there?
Is it 2x times y?
I see what you're doing, but it's not 2x times y.
Squared?
There you go, x squared times y. Length times width times height, x times y. You don't have to label these, but that's the primary. That's what we want to maximize. It's got two variables in there. I don't like that. I can't take it. Well, I could take a derivative, but it would be product rule and chain rule and all sorts of weird things. So I don't want to take a derivative of that yet. How are x and y related to each other? Like, what else do I know that would tell me something about x and y? What else do I have in here? Yeah, the surface area equals 156. Okay, so I need to add up all the surfaces. This would be where it matters that it's an open box. So let's see if we can visualize all the surfaces here. Start with the bottom. What's the area of that surface? Like squared. And then the other four are all the same. What's the area of this surface? So what's the area of one of those like panels on the side of the box? XY. And how many panels are there? What's that? 4 of them. So x squared plus 4xy equals 156. That would be my secondary equation. And you can see on this one that they didn't give you any equations. You had to come up with volume, and that wasn't too hard. You had to come up with surface area. That wasn't too hard either, but it took a little bit of thinking to figure out, what pieces to put together to get that. Now I need to combine them. I think there is a good answer on this. Would you rather solve this equation for x or for y? Definitely for y, because there's an x squared in there, so that would be terrible. So let's solve that for y. So 4xy equals 156 minus x squared. So y equals 156 minus x squared over 4x. And let's hope that this isn't awful. That goes in for y. So x squared times 156 minus x squared over 4x. Oh, this is good news. What's good news here? Why is that good news? What can happen? One of the x's will cancel. So I was originally thinking I'm going to have to do quotient rule, but one of those x's cancels out. So one of them will cancel, and then I could distribute the other, 156x minus x cubed, and both of those things are over 4. Let's see, x cubed, a minus x cubed graph. So this is going to look something like that, which means I might get 2 critical points, or I should get 2 critical points. So I better be careful on this one. I don't want to find the one that minimizes the volume. I want to find the one that maximizes the volume. So this one, let's see. I'm on alert on this one because I think I'm going to get 2 answers. One of them's going to be good. One of them's going to be awful. Let's see. 156 over 4. Well, let's just leave it alone. Take a derivative. 156 over 4 minus 3x squared over 4. So I'm just leaving the over 4s because when I set it equal to 0, I can wipe them out anyway. Take a derivative, set it equal to 0 because I'm trying to find these 2 spots. I'm going to multiply through by 4. Move the 156 over. Be really nice if 156 was divisible by 3. Let's see, 52. So, running out of space here. X equals plus or minus the square root of 52. So I did get 2 answers, but I'm not real worried now about which one I want to use. Right? Which one do you think would make more sense? The positive one. Look at the picture. You can't have an x that's negative square root of 52. That doesn't make sense. So, yet again, I don't really have to do a sign chart to figure out which one's the best one. I can figure it out. So x is square root of 52. But my dimensions are x and y. So here's my equation for y right here. So 156 minus 52 over 4 square root of 52. And again, how much you clean up is kind of up to you. You can just leave that as an answer and call it a day. I'm going to clean it up a little bit. 156 minus 52 would be 104. 104 divided by 4 would be 26. Square root of 52 probably reduces, but don't care. Safe stuff. Don't mess these things up. Alright, we'll stop there. So when I get you your worksheets, I would try 1 through 9. The worksheet only goes through 13, so we're well more than halfway through. So try 1 through 9. I'll just tell you now, Monday's assignment is going to be the rest of it. So if you don't get through it, that's fine. You'll just have a few more Monday to work on.